Hello, dear student. How are you? I hope you are all will be fine. I'm also fine. Thank you. Welcome to your channel. Let's start today topic. Today is lecture number 10 of nucleophilic substitution reaction. And today, like in previous lecture, we studied about the substituent effect. What is the substituent effect on the substrate as well as on the nucleophile? Here in today topic we will be studying leaving groups. What is the effect of leaving groups on the substrate? What is the effect of a leaving group on the substrate? Leaving group effects. Also we will study it in today topic. Both these topics are very simple. Also we will discuss today solvent effects on Sn1 reaction. First of all, leaving group effects on Sn1 reaction, while solvent effects on Sn1 reaction. We will both discuss them today. Let's start the topic. First of all, what is leaving group effect on the substrate? Leaving group serves two purposes in Sn1 reaction. Leaving group effect is similar as like the Sn2 reaction, is like in Sn2 reaction, as I already explained you. And the Sn2 reaction leaving group effect is also present. The lecture of this topic is also present in the description box, of the link is present. It has it has two main purposes. First purpose, the leaving group at polarize the CX bond. Polarize the CX bond. It is the first factor. It is the first purpose of the leaving group. The second purpose is it polarize the CX bond, so that's why the carbon become electrophilic. Due to polarization, due to high electronegativity of leaving groups. The another factor is it leaves with the pair of electron that once bonded to the electrophilic carbon. You can write it leaves with the pair of electrons that once bonded it to the electrophilic carbon. Yeah, it is this, like that is electrophilic carbon, that is double bond, that is bonded with halide ion. So here in this case, this bond, we know that each bond contains two electrons. So here is also two electron that is shared by covalently by both these atoms. So this why here this is the leaving groups. This leaving group, the purpose of this leaving group, the first purpose is it polarize the bond, so that's why the carbon become electrophilic. While the another purpose is it also leaves the lone pair of electron, it also leaves the pair of electron, this pair of electron with themselves when they are lifting the groups. So it become, the carbon become completely positive charge, while halide ion or leaving group become completely negative charge. So that's why this electron will be shifted towards or halide ion because of high electronegativity. These two are the basic factors of the, these two are the basic purpose of the leaving groups. But the good leaving group will be those leaving group. Now I am just summarize the topics further, but you can search it in lecture number 5 of nucleophilic substitution reaction, and their link is also present in the description box, so you can search from there with very details. These are the good leaving group, the factors that are explained in lecture number 5. The leaving groups are, those leaving group will be good leaving group that have the following character. First character is electron withdrawing group to polarize the carbon. It has the characteristic of this X, or you can say that this is leaving group. Electron withdrawing, electron withdrawing to polarize, electron withdrawing to polarize, as I already told you here, that at withdraw the electron, due to this withdrawing the carbon become polarized, so that's why they become electrophilic. The second purpose is stable or not strong base. You can say that stable ion produced Once it has left, once it has left, it is the another factor. As the become, as the halide ion is the leaving group become left the system, it will become stable. When this is stable ion, when this is stable, it means that the reaction will be go, the reaction will be undergoes Sn1 reaction or Sn2 reaction very rapidly or very good. It also means that it will be good nucleophile, it will be good leaving group when it has stable, when it has left. Yeah, this is the third point. This is second point. The third point is the polarized. It has the property that polarization, at polarizable to stabilize the transition state, to stabilize the transition state. Yeah, it has like that. It has like that. This is the transition state. Let's suppose this is the transition state. When nucleophile attack on the carbon, it become like that. This transition. We know that carbon has 4 covalencies, so that's why carbon only make 4 bonds. As the nucleophile attack on this carbon, as the nucleophile attack on this carbon, now the carbon should leave, should break one bond, one of the bonds. So that's why the bond that are more polarizable will be breakable. This bond, the bond between carbon and electrophilic carbon and the leaving groups. So when the carbon partial, when the nucleophile partially donate electron, means this bond partially formed. So this bond will be partially breakdown. In these cases, the electrophilic carbon, this carbon gain this carbon gain partial electrons from the nucleophile. So that's why the carbon become negative charge, and this negative charge will be stabilized by this leaving group. So when this leaving group is good leaving group, when this is good leaving group, it become more, it become more, it withdraw more electrons. So that's why the transition state will become stable. So those leaving group will be good leaving group when they stabilize, when they more polarize, when they stabilize the transition state. So these are the properties of the good leaving groups. Good leaving group will be those good leaving group, those leaving group will be good leaving group that can withdraw electrons strongly. Those leaving group will be good leaving group when they produce ion, when they are stable, when they are stable, when once it has left. And also those leaving group will be a good leaving group when it has polarization, high polarization property to stabilize the transition state. I already explained you these 3 points in very detail in lecture number 5. You can uh, search in YouTube also, in description box a link is present of lecture number 5. The effect of leaving group in Sn1 reaction and Sn2 reaction both are same. So that's why you can search, you can watch from there lecture number 5. Okay, thank you. The second factor that affect the Sn1 reaction is solvent effects. Solvent effect on Sn1 reaction, on Sn1 reaction. We know that here is only two types of solvents. So one type is it may be polar, with polar may be that is maybe protic or aprotic, polar may be protic or aprotic, protic or aprotic, while the another solvent is, we know that it is non-polar, non-polar. Also we know that in Sn1 reaction, in Sn1 reaction, the ion produce ionization, due to ionization, due to ionization, due to ionization, ions produced, ion produced, it is the product of the Sn1 reaction, of first step of Sn1 reaction. So ions will become stable. Those ions, when the ions are stable, it means that the reaction will be go very rapidly. The marker is not properly working. Let's change. This is the Sn1 reaction, first step of Sn1 reaction. This is carbon, that is X. In first step it become polarized, it become ionized, electrophile plus, that is halide or leaving group, that is negative. So those ions are those, this is the slow step of the Sn1 reaction. So this step will be very rapidly. When this step, when the rate of this step is high, it means the Sn1 reaction, the speed of the Sn1 reaction will be more. So this step will be high when the ions, when the final ions, these ions, when they are stable, and the stability of these ions will be increased by this solvent, by solvent. So as the solvent, as the salvation power of solvent increases, it mean that these ion, the stability of these ion will be increased. As the salvation of, as the salvation of, as the salvation, as the salvation is the power of salvation, as the power of salvation increases, as the power of the salvation of solvent increases, it means the stability of the ion will be increases. Stability of the ion will be increases. So that's why the salvation power of polar solvent is very high. Salvation power of polar solvent is very high. Like that is H2O, that is alcohol or water. These have very high salvation power. So that's why those solvents that have more dielectric constant, those solvents that have more, that have more dielectric constant, more dielectric constant means greater the dielectric constant, greater will be the solvate ions, greater will be the ability to solvate the ions. So that's why when these ions are strongly solvated, that's mean the reaction, the rate of the forward reaction of first step will be very high. So when this step is very high, the another step, the second step, we already know that the second step is the fast step. So become, so it means that this Sn1 reaction will be very rapidly occur. So these are the effect of solvents, as well as the leaving groups effect on the Sn1 reaction. So those Sn1 reaction will be very high reaction in which solvents are, in which solvent have more dielectric constant. More dielectric constant mean at ionize, at salvate the ions of the first step of the product, the at ions, at salvates the ions of the first product, first step. So due to this step, this is slow step. When the rate of the slow step is high, it means that this net net speed of the reaction will be very high. So these are the effects of the solvents and leaving groups on Sn1 reaction. I hope this point will be clear. If you have any confusion, if you have any question, you can also ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I drop in description box. You can get from there. Also, please subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck, my dear student. Very best of luck.